For example, ZF calls DNA of quality. In DNA of quality, there are 5 Ps, more or less comprising of whatever I said: people, process, perception is the customer feedback, PDCA, and the process. So, living quality. So the whole idea there is the whole organization lives and breathes quality. Everywhere we look at. But that is now moving into, so till such time the focus was output of an organization. Is there a, yeah. I'll come back to this. So, for example, an output of an organization earlier used to be profit. So of course TQM brought in a culture of customer focus. So the important stakeholders used to be the investors and the customer. But then if you see last 10 years, more and more the focus is on the societal aspect, social dimension. That's where you have this ESG and the sustainability part comes in. Of course, in India, we also know that 2% of your profit, you have to contribute to the social CSR activities, etc. But that is one level. Much deeper understanding of this topic is whenever you manufacture, whenever there is a business activity, whenever there is a manufacturing or any activity, there is you are actually consuming power, consuming energy, consuming resource, consuming many aspects of that resources. When you consume, then the idea is how long that will stay. Can you really continue to consume like that, or you need to really look at renewable part. So the idea of reuse, renew, 3R principles. Also in the design, how do you really look at the product design? Have you designed to the environment, design for environment? Is it recyclable? Are you using the right material and the right weight, etc. So weight reduction, all those things became an important aspect. But if you really look at the sustainability dimension, every aspect of the, I'll just go to the, yeah. So every aspect of the manufacturing or a business activity actually leads to some amount of carbon footprint. So if you see a part is designed nowadays, we are calculating the product carbon footprint. So there is no activity in which you machine a part, for example, you are actually consuming energy. So every activity there is a carbon footprint. So that is calculated, and then you also take action to reduce that product carbon footprint, etc. The whole organization actually looks at how we can really use the sustainability dimension to the best of the societal benefit. So actually here, that's what I have said here. Traditional quality is largely compliance, efficiency focused, and customer satisfaction. New reality is business is judged by impact on society, environment, and the future generations. Efficiency without sustainability is incomplete quality. I talked about this, actually we have to evolve from an inspection and compliance towards from there to a strategic enabler for responsible growth. So we have to bring in responsibility into this. So now people talk about responsible supply chain, responsible management. How do we management of resources? So actually quality should embed quality into every business process, not just the final product. That's what we talked about, the evolution of the quality. More from a control mindset to one focused on continuous improvement and value creation. Finally, the important aspect is incorporate sustainability, innovation, and stakeholder expectations into quality objectives. So the quality systems should integrate sustainability into design and process by proactively including sustainability in every design and process design, from materials choice to end-of-life strategies. Organizations build resilience, reduce risks, and create value for their business, customers, and society. So the societal dimension is an important aspect. So that is going to be the main point of our discussion today. So we have three eminent panelists here, and I will just introduce you all the three of them. First is Mr. S. Harikrishna. He's a Deputy Director, System Reliability Safety. Mr. Harikrishna has a BTech in Mechanical Engineering from Jawaharlal Nehru Technological University, Anandapur, and ME in Aerospace Engineering from IISc Bangalore. Contributed in the realization of light alloy structures realized within ISRO and outsourced work centers. Identified opportunities for quality improvement. He has published papers in seven national and 7 international journals. Has won national award by Indian Society for Non-Destructive Testing and ISRO team award for the design and development of dual gridded antenna reflector. Currently, he is Deputy Director, Safety, Reliability and Quality Area, Human Space Flight Center. So let us, on behalf of you, I would like to welcome Mr. Harikrishna. Then we have Mr. S.P. Joshi. He's a veteran from Tata Group. Mr. Joshi, I know him very well. He was our customer for most part of my career. Of course, when he superannuated, he was the head of service, global service for the whole global Tata vehicles, and also aftermarket related supports to the customers. Prior to that, he was leading the quality organization at Tata Motors. Very well-known leader within Tata Group, and he has worked more than 40 years in the field of course, customer care and quality in automotive field, including, as I said, head of quality for Tata Group, for commercial vehicle Pune plant. He has designed, developed, and established multi-acre advanced driver training institutes in India and abroad. He has received many awards, including the Customer Service Leader of the Year, People's Choice Stevie Award for Favorite Customer Service by Stevie Inc., Las Vegas, USA in 2012. Business Leader of the Year Award, Miami, USA 2011. Also the coveted Rajiv Gandhi National Quality Award in 2007. Mr. Joshi also has written a book on, in the auto components, how do you maintenance of the auto components, how do you really do correction and improvement of those things. So, and again, I'm very pleased and honored to invite Mr. Joshi to be here today. Yeah. Finally, we have Mr. Sundaram Ramasamy, a well-known name in the aerospace and defense sector in India. Mr. Sundaram is the founder and managing director of the Salem Aero Park and Aerospace Engineers Private Limited. He has been elected as a member in many governing boards, including Dr. MGR Medical University. He was nominated by British Deputy High Commission for Trade Mission in Aviation and Defense sector to participate in the national level trade mission in the UK, organized by British Deputy High Commission, Chennai. He has won many awards, 2 awards from the Prime Minister of India. For the best MSME company, and he has done a lot of work in localization of products in that industry. And I think the Salem Aero Park and the initiative that he has taken in Salem is one of the pioneering initiative in Tamil Nadu in this aerospace and defense corridor activities are very well known in Tamil Nadu as well. He has been winning many awards from the government of Tamil Nadu as well. Of course, the accolades are too many. As I said, 2 awards from the Prime Minister, 2 more from other ministers of MSME sector from the Government of India as well. Again, it's an honor to have Mr. Sundaram here today to share his experience with you. He is very passionate about building the defense and aerospace business from India. As I said, we need to build the India brand globally. And Mr. Sundaram is an example of what can be achieved from here. He's already exporting to many global aerospace and defense organizations. He's been one of the supplier to the the missile programs as well. He will probably share with you. And he has got a contract with one of the Egyptian organization to supply for parts for defense and aerospace for defense for another six years, etc. So very well connected to the global supply chain. I would say a benchmark for MSME industry. So again, thank you, sir, for joining and participating in this. Now we will we'll go to the session. So we would first request Mr. S. Hari Krishna to take the podium. Thank you.
Can you load the presentation? Thank you, Chairman, and I am really humbled to be here, actually among the stalwarts, and really thank you thanks to NIQR for giving this opportunity. Actually, I joined ISRO in the year 2000, and from there, I've been part of the process. So a few thoughts when the organizers, actually I came in as a substitute for P.K. Abraham, sir. So when day before yesterday he called me and that he could not come, and he asked me, then I was just really thinking, what can I talk about on this topic? So then I tried to put in 3 segments. One is I can talk about from my side where I am more comfortable. So one is about the space and what made quality improvements and sustenance possible in ISRO. Second one is some case studies from where I have little bit of experience, and a few thoughts for share based on my interaction with the industries. So I just thought I'll share from my side. So this we all know that all the digital devices which are there have vanished into thin air. The reason? Mobile. And the mobile communication is actually through space, one of the applications of the space. And can we guess what is that image? Any guess from anybody? Yeah, it is actually Earth photographed from the other side of this one. So we know that Earth is round by getting elevated into the higher levels. So many of these things are possible through satellites, So these satellites are able to provide the insights from Earth to universe and its creation. We are looking towards Earth to know many of the things like weather prediction, any real-time updates about what is happening around us, even crop, the greenery, everything about the earth, that is happening, and also to our source, how the earth has been created. That we are able to get into by looking into the galaxies. So these satellites are for peace as well as for war. Okay. So for the satellite to be kept at a higher level, what we require is we need to put, so it goes around the earth, and that orbit, once we keep it, it will do the job. So to keep the satellite into the orbit, we need a launch vehicle. That launch vehicle we need to create. The entire thing actually has started with one visionary, that is Vikram Sarabhai. It is actually, there is a vision and the visionary, which is great if we talk. Actually, the vision of the visionary is the great. It is a very, very important aspect. If you recollect in the words of Swami Vivekananda, he said, dear sisters and brothers of America, and there was a thunderous applause. But then later he reflects, the same words were spoken by the previous speakers also. But why he only could get that response? He says, it is not the words, but it is the force behind those words. And he says that one as the force behind the words is actually brahmacharya. That's why he could have that power, and when he uttered those words, those words could reverberate among those things. So that is the kind of vision the visionary had, and that is making actually ISRO run through all these stages. And so he said rightly that a meaningful role if we want to play, we should be second to none. And see the kind of personality he was. The variety of institutions, many institutions he was the originator or the founder. Apart from ISRO, he had so many things, defense, not just defense, physical, heartbeat, BAE area, or even Darpan Academy, like IIM also. So the kind of visionary is that quality of the leadership or the thought process is what actually can make the quality sustain and further make the contributions for growth. So he is followed by the able leadership, and the famous question that is asked, what is the most precious thing on earth, by our beloved Abdul Kalam ji. He asked this question, and then he asked whether it is gold or diamond or rare earth material or anything. Then he says no, it is ignited mind. That ignited mind is the one which is required for the improvement and sustenance of the quality. So this is what they did. They did not tell that you build the ship. They inspired the people, and the entire nation, not just the ISRO, it is actually entire nation, the organ is actually inspired by those great visionaries, and we are able to do whatever we are able to achieve this one. From the pencil rocket which are handheld till the Mark III and further. So this is what they've made it possible, like teamwork and delegation. They did not tell you do this way. They told this is what we want. You do in your way. That is how actually quality output could come and we could get the results. So coming to the little bit more technical, what actually launch vehicle and spacecraft, how they differ? One thing is the very high energy density. Within few seconds or 17 minutes, entire 200 tons of propellant and 210 liters of this one of other propellants. So everything gets vanished into thin air. Then operation environment, pressure, temperature, acoustic environments, very high, severe. Single time usages thick systems like Pyro, and highly complex interdependent multidisciplinary performance requirements, and with very narrow tolerance limits. And that's what. So everything is complete in few minutes. There is no, the error for, the error chance actually has to be very, very limited, otherwise the mission will not be a success. So, and then spacecraft also, they are unique and one-off, and rapidly changing end-user requirements. Then operational environment, thermal and vacuum conditions, and dimensionally stable environment. The solar panel which is kept, if it gets bent, the energy is lost, so it has to be very stable. So, all those things, how do we do that? It is actually, as the previous speakers mentioned, it is about the management of interfaces and interfaces. That in the technical as well as managerial, it is a people-centric system. That is what will make the things possible. So, how the launch vehicles, it works on the principles of Newton's laws, 1, 2, and 3. So, and if you see how the typical launch looks like. So, at different stages, it has to get separated, then push the remaining part, and then, so actually that is releasing the dead mass. So, the used spent stages fall down. Similar way, we have to let go of our really sentimental things in order to progress further. And so, at every stage, it has to perform with a precision activity. So, for this, it is not the ship or the launch vehicle, but it is a launch vehicle building entire systems that are required for building those launch vehicles and launching. They are very huge and to be operated by multiple agencies. This is one of the SHAR, this one. And so that is about the launch vehicle and spacecraft systems. The real difficulty is actually that based on the number of launches and other things, the volume required at any point of time is actually very minimal because of the dynamic requirement changing also. So that is why anything has to be thoroughly analyzed, and then only a decision has to be taken with a concurrence of all the people, then only we can do that. So coming to more technical side where I come from, like two case studies, how the improvements could be possible. So a brief, this one, composite structure, actually there is a resin and reinforcement, to put together it becomes a synergetic behavior. So multiple types of constructions are possible, and these are different types of structures that are made and used in the launch vehicle and spacecraft systems. And Professor Satish Dhawan says, like, this is an arena where parameters of fabrication are part of design, and design is part of fabrication, and both have to be integrated into one place. Very aptly summarized. So actually in metals, what do we do is, we take a metal of known properties, machine it or weld it or do whatever integration, and the properties of the material is same, but here we can change the property or according to the direction, like wire. The wire can be, if we pull it down along the axial length, it can take a lot of tension, but compression it cannot take, and sideward force also it is very weak. So this kind of behavior we can actually fine tune and design the structures, then get its best way of performance. So there are different kinds of defects that can come in these things during manufacturing, handling, machining, and in this NDT actually it gives a right input at different stages of manufacturing. When you make a part, when you assemble the parts and make sub-assemblies, then assembly. So multiple locations. So the correct raw material and production process we have to do. Then we have to check for the dimensional accuracies. Then NDT assessment. If it is fine, then with NDT itself we can accept. If not, then we have to do some additional tests. Then with increased confidence or increased experience and understanding, we can go to limited testing, destructive and physical testing, then accept it. So why NDT is required is actually it can provide the differences in the material characteristics more effectively. And the destructive testing we cannot do on the parts or assemblies because they cannot be used. Non-destructive testing, we can use the part even after testing. That is where the name itself comes. So the variability is better captured by NDT. That is what is giving this one. So what makes it difficult is or different is compared to the metal is actually they are layered in structure. Compared to a metal, they are stacked one by one in general or wound. So it does the ability of general NDT methods are very limited. So you need to customize your NDT methods or specific NDT methods. Multiple failure modes are there. And main thing is about the acceptance criteria. There is no, if you say metals, you have many acceptance criteria, ASTM, all those things. But here, there is no acceptance criteria. You have to decide. And another difficulty is generating the correct reference specimens or calibration standards. These are not available in public domain, have to be made within the organization to the requirements. So there are many techniques, but one thing is what is the performance required and what are the procedures and standards and what is the time available. As a component, you may have some time, but when it gets final stages, limited accessibility as well as limited time also can be there. How do you deal with it? So you need to